Hi students, in this session we are going to learn about the tests that are going to useful in detection of the organic compounds and functional groups, right? Since all functional groups cannot be discussed in a single video, this is going to be a series of 5 videos, and in the first video we are going to learn about the tests to identify the unsaturation in hydrocarbons. Okay, so I'll make another video which is to find the alcohols and phenols. And in the third video, I am going to discuss about the tests that are pertaining to carbonyl compounds. And in the fourth video, amines and carboxylic acids. And the fifth video is very important. Carbohydrates, proteins and fats identification is going to be discussed in that one. Okay. So in this session, we shall learn about the test to find out the unsaturation in hydrocarbons. Of course, there are 4 tests available. The first one is bromine water test, and second one is Bayes test. Third one is Tollens test, and fourth one is Felling's test. So in bromine water test, when an alkene is added with the bromine water, bromine will be added across the double bond and the addition is anti-addition. Since bromine is going to be consumed in this reaction, the bright red color of bromine will be decolorized, which is the indication for unsaturation. So we know that this bromine is red in color, right? Red color liquid. And when I add a bromine to alkene, anti-addition will happen. Anti-addition will happen, which means bromine will be added here and another bromine will be added here, there, right? Since bromine is going to be consumed in this reaction, the resultant product, the product which is obtained as a precipitate, will be colorless one. So I can say that bromine water has been decolorized. So this is a test for the unsaturation. When I take an alkyne and add with the bromine, it requires 2 equivalents of bromine actually, and see, so bromine will be, both the 2 equivalents of bromine will be consumed, and again decolorization of bromine water will be the result, and again this is the indication for the unsaturation. So in Bayes test, Bayes reagent is nothing but cold dilute alkali solution of potassium permanganate. Okay, so this is a reagent which is used for dihydroxylation of alkynes. So when you add a Bayes reagent to alkene, dihydroxylation will happen, which means addition of 2 OH groups on both sides, and this is a syn addition. Okay, so the resultant product is a diol. Now the pink color of potassium permanganate will be decolorized in this reaction. So that is the indication for unsaturation. Okay, when I take an alkyne, it requires 2 moles of the potassium permanganate will be required more, and the product will be oxalic acid. Oxalic acid will be the product, and here also the decolorization of potassium permanganate, which is the indication for unsaturation. So in Tollens test, ammonical silver nitrate, Tollens reagent will be added to alkyne, right? Ethine. Okay, when ethine is added with this Tollens reagent, silver acetylide will be obtained. Silver acetylide is CH triple bond C minus Ag plus. That is because of the acidic hydrogen present over here. Acidic hydrogen is because of more electronegative carbon, that is sp hybridized carbon to which this hydrogen is attached. Okay, if I take an excess amount of this Tollens reagent, then this hydrogen will also be removed. Okay, so in that case I will get 2 silver ions present on the opposite side and on either side of the triple bond, and this is known as disilver acetylide. This is the product, and this is a white precipitate which will be obtained, right? White precipitate, and this is the indication for the unsaturation. And one important thing you need to note, this reaction involves the replacement of acidic hydrogen, and acidic hydrogen can be present only in the terminal alkynes, right? So this test will be answered only by the terminal alkynes. So alkynes like but2-ine will not answer. See, butane 2-ine formula is C triple bond C CH3. This alkyne will not answer for this test because it doesn't have terminal hydrogen. This doesn't have acidic hydrogen. The last test is Felling's one. You know that Felling's solution is a mixture of Felling's A and Felling's B. Now Felling's A is nothing but copper sulfate pentahydrate solution, right? Copper sulfate pentahydrate, and Felling's B is sodium potassium tartarate. Sodium potassium tartrate. It's a salt tartarate. Okay, it's a salt and it's also known as Rochelle salt. So equal amount of solution A and B will be mixed together, which will be called as Fehling solution. It can be used to identify carbonyl compounds predominantly, but here it is also used to identify the alkynes, right? So when ethine or terminal alkyne is added with the Fehling solution, we get copper acetylide. Copper acetylide will look like this. Okay, this hydrogen again it will be removed and you will get this compound. This is known as copper acetylide, and when you take excess of Fehling solution, then you will get a dicopper acetylide. Okay, which means both the sides, the acidic hydrogens will be removed, and you will get this one. And this is red in color. Okay, this is red in color, and this is an indication for the unsaturation at the terminal carbon. Right. So remember, guys, this tolerance reagent and Fehling solutions are useful only to detect alkynes, not alkenes, not alkanes. Okay, the compounds which have triple bonds, and that too, the triple bond should be present at the terminal carbon. Okay, that's all for now. Thank you, guys. Please subscribe this channel. Please comment and share. Thank you again.